Hello, everyone. Uh, my name is Mohammed Rilwan, and in this research, I'll be talking about using virtual machine-based containers as honeypots to detect malicious behaviors. So basically, my research was done on developing honeypots as a detection tool in order to detect malicious behaviors, trying to early detection, trying to attack, trying to find an attack early, and trying to find the attack patterns and to learn the techniques. I thought, and generally, honeypots are a wonderful tool to experiment these because we are looking in a non-production, non-business tool. So this is trying to mimic uh, a real-world application, but in honeypot, what we are trying to is move more into research. And what is the primary purpose is trying to the main is to detect malicious activities. The reason being is that with the increase of cyber attacks, it is getting more advanced that the tactics that the attackers use, and it becomes very sophisticated, hard to detect these. And using honeypots, we try to build to mimic a real application or information system uh, with the primary goal of deceiving attackers in order to gain information of adversaries. So trying to understand the threat landscape and of the the application or the organization, how who are the bad guys and what they want. To understand their motives, the honeypot becomes a very important or good tool. So, what is the motivation for this? The objective of this research is, as I said, is to develop a container-based web application, Honeypot, that will assist an organization to gain information about their threat landscape, and in order to implement preventive actions to protect the organization. And one of the most important things that we have seen is that in 2019, in a DBIR report, that we found that the web application attacks are not get stopped, right? I mean, it is not stopping. We are seeing high in number of increase, and every year. And in DBIR in 2019, they report that 39% of breaches that happened in 2019, uh, they were from web applications. And web application was referred as the number one cause for global breaches in the DPI report, which is the 39% of the breaches. And why is that? Is that many reasons being like programming flaws, configuration errors, and this led the advantage for the attackers to uh, compromise these and gain control of these devices and steal information. And in 2019, in the DBI report, is also reported that 71% of breachers were financially motivated. So, I mean, this is what the drive for the attackers to steal information and especially break into web applications. And how can we understand uh, the uh, the tools or the way how an attacker attacks, and this requires time and effort, and honeypots being a great tool to investigate and to experiment what are they doing on, right? I mean, that is the primary goal or the motivation behind the objective of this research is. So let's talk about the related research. A lot of devices, honeypots, have been experimented, uh, and there are multiple research you could find on this. And for years it has been, and honeypot is not a new thing. It has been for years, and many people have published papers on this, and many research very old in even 2000 and 1900s, 1990s. uh, there are research on this, and one of the research, I have captured three of them, but there are more that on honeypots, but these three have different flavors of honeypots, and very advanced honeypots. And one of them, the first one, is a multi-component honeypot, meaning it is multiple components that they experimented with three open source honeypots, which is one is Cori, other one is Dione, and other one is Glassed Ops, which are the three names of the honeypots. And the first one, which is the Cori, which is a Linux-based honeypot, and then the Dione, which is a Windows-based honeypot, and Glassed Ops, which is a web application-based honeypot. And they were running in container, Docker-based container, and Elastic Stack was used to capture the data, and the virus total was used for threat intelligence analysis. So this is the style of honeypot that they use different. I mean, here we saw three different, which why they call as multi-component based honeypot, and so they get more data, and that's what they use Elastic Stack and virus total for threat intelligence and for reporting purposes, in order to identify who are the actors are, and why are they trying to attack, and for that purpose they have developed in a such a manner. And and the next honeypot that we are looking at is Honey Drive, which is also very interesting. It's a virtual hard disk offered in an open virtualization format, and it's ready to be imported in a virtual machine hypervisor. It comes with many honeypot and malware related utilities pre-installed and pre-configured to work in an out-of-the-box fashion. A number of virtual machines like this could be set up in different IP spaces in order to capture data. So it's very advanced, and to accumulate different data sets for analysis. The data log from different from an operation of kind of to be used to create like blacklit databases, and the so it's a very advanced level of honeypot is the Honey Drive honeypot, and you could read that, which has been cited in the paper also. And the third level honeypot, they call it as a all-round honeypot, which is HoneyDoc. And the reason why they call it a all-round honeypot, which means that significant improvement in sensibility, countermeasure, and stealth are done on that honeypot, and it is also a bit of advanced honeypot. And the honeypot HoneyDoc architecture uh, is also based on that, like SDN, software defined networking, and it's a software defined networking enabled honeypot system, which supplies high programmability for technically sustaining the features for capturing high quality data. So these are very advanced level of honeypots, but our research is a very entry level or standard, trying to get a feedback on the honeypot area, and developing in a honeypot. And this is the research is to get that experience and exposure of what does a honeypot and how can it be built, and this is a very entry level step that was taken, and the implementation that we have done is using a virtual machine, yes, and using Ubuntu virtual machine, and hosted in DigitalOcean. And we use SQLite for database to store the data. I mean the logs, I mean the traffic, and the events, basically, in order to study the actions of bad guys, right? And then also we use Splunk as a reporting engine. So once we get this data, it is also it's not fully automated. We done it a bit of manually, that we pull the data from SQLite into CSVs, and then we feed that, we ingest that into Splunk, and then build dashboard out of it to see where does the attacks coming from, and how many attacks that we are getting from that IP or from that region, and we build analytics out of that, and also to see what kind of attacks are there, and what has been happening. So basically, to give an understanding, our approach of is a very basic approach that we have taken to develop this honeypot. It is a virtual machine, as I said, and then we have it is running using Python. Python it's a web server, web application based honeypot, and it is looking for the request, and it is seeing basically in order to attract the attackers, what we have done is that we have shown we have we kind of fake it out. I mean, trying to show that this many vulnerabilities are there. I mean, having paths, right? Having directory structures built like those are like vulnerabilities, but they are not vulnerabilities. But to attract the attackers, because attacker will be using an automated tool in order to find what vulnerabilities are in this device and so on. So when we have so many paths like this, which are like acting like there are vulnerabilities, but actually there is not. All right, there's a Python-based web server, but here we are hosting like a PHP kind of a sandbox site of a WP, WordPress application. But these are the paths are being established or pages. But when you go when you type this on the URL, it will not go to the real WordPress content, but it will go for a fake page. And we are trying to. This is one of the ways of attracting attackers that we have implemented in this tool, where we have fake paths showing that there are some vulnerabilities. So come and attack the system. So in order to attract the attackers, we have done something like this. And also once the user or the attacker goes to that path, what we do is that we try to extract and classify what is that pattern of that URL is, right? I mean, this URL shows many things like a get or a head or a post type of URL, and also what are the strings, the pattern of the string, which use to we use an XML in order to identify and uh, classify what kind of attack it is. So it's a PHP code injection, it is a it's a SQL injection, and so on. And using the regex pattern, as you see in this XML, we use a similar structure in order to what you call uh, 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 classify the pattern of the attack. And once we have this data, right? I mean, once we know when we classify what kind of attack it is, which source is it, what is the IP address of it, what is the port number that the request is coming from, is it a get request, is it a post request? When we get this data, we put into the database, and then we save it in a table in order for us to analyze. uh, and these requests are limited that we have put, but you could go a huge amount of list. I mean, to understand more types of patterns and so on. So right now we will try to do a quick demo of this. Okay. So I'm logging into my Ubuntu virtual machine, and then on the background you can see another command prompt. That is, this is connected to the I have already connected to the DigitalOcean, and my server is running there, and this is my IP address, right? And so, for example, to show how as think I'm connected, so it's my Ubuntu machine, and I'm trying to run an nmap scan against that IP address, which is my uh, server for the Honeypot server, web application server, right? And then I'm trying to run, and you would see on this command prompt now what will it look like, how it will collect the logs, and it will try to display the I mean any bad thing is happening, it will try to show it here. Let me see, it's not starting yet. So scan is already started. uh, it's not yet, it's also loading. And as you see, it is showing collecting a lot of logs, and these have been saved in the basically the database, and also we have a log file. And basically what you are trying to see is that it is our nmap command is running a vulnerability script, and then the requests are being sent to my server, which is a honeypot server, and the honeypot server is listening and taking them and logging. And that is the job that honeypot does. So that is just to visualize what does the honeypot does and what we have built here. And so that is, and once that is done, and just to go inside the directory, let me show. This is inside the our in DigitalOcean virtual machine. And so we have a log directory, we have a data directory. And so basically inside the data directory, we have those pages that we are faking out to attract the attackers, but these are not real pages, real vulnerabilities, but they look like vulnerabilities in order to attract the attackers. And then the database is where DB, where all the logs have been saved, and also we have a log directory uh, to store the raw logs. And as you see, a couple of logs files. So that was good. And so let me go back to my previous machine. Yeah, Google Chrome. Yep. So and one thing to also to show is that once that is basically done, I mean, once we collect the logs, we we from the database we extract to CSV the tables, and then we feed them, we ingest them into Splunk, as I mentioned before. And here what we are trying to say is that the dashboard is built from Splunk, that it shows that where does the attacks coming from and what are the IPs, and most of them are coming from, as you see, from Russia, which is almost 70%. And also if you see cities, they are from most of the Russian uh, cities. And that is where we see most of the attacks coming from. And in this 24 hours, right. And also one more thing is that we look into is here is what kind of request does that the attacker makes. And also try to get the count of it, and to analyze what kind of URLs the attack is looking at, and so on. So and what pages they are looking at, and what directories are they going to, and what kind of if they are like trying to post, what are they posting. And so basically in this request URL, we are looking into such kind of data basically. And that is what we have done here. Okay, that's good. And let's go back to the PowerPoint. Okay, sorry about that. Okay. So we talked about the implementation. We did a demo, and we showed the results as well, that most of them were coming from Russian countries, and the attacks were. And then what we have been looking at are the request URLs. We have not seen so far any post request. I mean, we have been running this for 3 days, last 3 days, and we have not seen any post request yet. And most of them are like get request and head request. So post request will help us to understand that it is also it might be a SQL injection, and what kind of post it is, right? And then the conclusion and future work that we're looking at is that we have so far we have found within 30 minutes the server was launched. We saw that in 24-hour window, our honeypot attracted 80 plus attackers. So this is what we're trying to say, is that there are a lot of many attackers out there. They're trying to look for weaknesses and trying to attack devices to get data, to compromise devices. So what we have experimented is that within the short amount of period, we have been attacking such a large number of attackers. So our goal is that this is a very entry level stage that we have been experimenting this honeypot. We would like to extend this more into looking into like tailored responses. Right now the response is not much tailored. It is like a regular response. I mean, the tailored response basically means once the attacker requests something, the request should be the request that we are sending back. Like as we saw before, that our approach is that we try to fake out the vulnerabilities. So when the user requests a vulnerability or he's trying to do a SQL injection, the reply that comes from the server should be that it should not be showing that this is coming from honeypot. Is a real server sending. So that tailored response is something that is very high level thing that we would like to work on, and this could be worked through a lot of automation and machine learning, and we would like to look into these options in future. And that's it. Thank you so much. And if you have any questions, uh, please email me. Thank you so much.